Hello guys, the Mutable sample project has been updated to 5.6. It has a lot of new stuff, like a lot of morph target for the body, for the head, okay, here, for the nose, for the lips. It's a lot of work. But you have a spaghetti here, you have another spaghetti here. So I am not saying that this project use all the functionality that it will use if data tables are incorporated inside Mutable. I don't know if that is by design or if there is some reason why this is not merged inside a database, because this is a spaghetti, a horrible spaghetti. I will try to fix that in my project, and this is just for one character. Imagine several characters, but well, that's not the point of this. What I want to say is that my fears become real. All this new stuff break the all Mutable sample project. So if you were working with this project, with the Mutable sample project in 5.5 or below, you will not be able to upgrade to 5.6. It will break the project entirely. There's no way that you can actually could update this unless you code fix the plugin itself. So all the people that start using this and start working with this project now have to redo everything and start from zero, or abandon the project because there's no way to upgrade 5.6 to 5.5 to 5.6. Sorry, Epic's doing epic things again. I don't know what's the problem with that. Probably because Mutable is better. We already talked about that, and they are constantly adding stuff here. But let me show you what that means for this tutorial. Okay, for those who doesn't know, in this video I update the project to 5.6. Here you have the project and the mannequin that you need to add, and with that you will start from the 4 class. Okay, so you don't need to start from 0. You can start from the 4 class and do directly the 5th class of the tutorial. If you haven't done that before, that for those who are actually doing the tutorial since the beginning. For those that are just starting, they can just start from 0 without any problem. Okay, so those who didn't update the project, you will not be able to. So my suggestion is to start from 0, abandon the tutorial, or download the 5.6 update, which puts the tutorial in the 4 class. Okay, and then you need to do the 5 one and this class, the 5th, the 6th one, the 6th. So that I'm sorry, but that's the way it is. I hope that in 5.7 the Mutable project, or I would say the Mutable plugin, doesn't break again. But well, that's how it is. Okay, let's start by opening the VPC character assembler. We will use only this blueprint in this class, and here we need to create 4 functions. The first is gonna be called create body meshes map. The second one is gonna be called set meshes collision. It's gonna be character assembler, and we also need a function that we will use inside the create body mesh map called populate meshes, and this one will have two inputs. One is gonna be a skeletal mesh actor component of your reference, and the second one will be a structure, this character assembler. This one is character assembler, and we're gonna call it character data. Okay, and we will create the body mesh map first. Then we will set the meshes collisions. And finally the character assembler. And inside this one, we're going to use the populate meshes there. Okay. And we need a custom event here to toggle the visibility of the meshes. We'll do that later. But this is the basic structure. Okay, let's start here. Create body mesh map. We need the character DA. Skeletal mesh data. This is the map. We need to get the keys. And for each loop. Remember that here we have body parts. Okay, next let's search for spawn actor from class, and the class will be skeletal mesh actor, this one, and split it in 4. Always spawn ignore collision, and the owner will be the get owner, which is basically the character that we're using, because this component will be attached to a character. And basically what we're doing here is to create a skeletal mesh per body part. Each body part we have set in this map will spawn a new skeletal mesh. For example, you have here a body and a head, you will spawn 2 skeletal mesh, one for the body, one for the head. Okay, and now we need to set everything. So we'll find from this map, from the array element, and this is gonna be the character data. And from here we'll get the skeletal mesh asset. This one skeletal mesh as skeletal mesh component, and this is go here. So in this function we will feed the skeletal mesh component and all the relevant information from our map. There. Okay. Okay, before we continue, I made a mistake here. This body mesh map is incorrect. It's not an S character assembler, it's a skeletal mesh component. Okay, skeletal mesh component. This component basically. Sorry for that. Okay, so now we can add in this map this component, and from here the enum we get this part, and with this we have a body map with all the skeletal mesh that we have spawned associated with the corresponding body part. Okay, there. There. To summarize, we get the specific data asset. we get from there the skeletal mesh data, which is basically what we built inside the data asset. We iterate through each body part, and for each body part we create a skeletal mesh actor, and we pass a reference of the skeletal mesh component and the relative structure for that body part to our next function. And finally we create a map that we will use later. Okay, so, and then we return. We will need to start working here. Okay, the first thing that we're going to do is to make a sequence with 3 ways, and we need to get the character data from here. You have this F and arrow in the top right corner that indicate that this is actually a root node, basically from here to here. And we need the SKM, same icon, the top right is a root from here, and we need this 3 times. Actually we need probably another SKM, it doesn't matter. Let's start working with the first part. Okay, let's break this. And for here we need a tag. We need to check if it's not empty. It's not it's not empty, sorry. It's not empty. This one. And if it's true, that means that we have some tag here. We will set the tag of this set tag with these tags that look here. This is the first part. Remember that in our setup, okay, let me check core. No, I want to show you here on gas blueprints. The mesh doesn't have a tag, but the retouched one, this one here, for example, many, in the skeletal mesh component below this character mesh, in this many one, we have the generic retouched, we have the skeletal mesh, and we have tags. Okay, these tags are the one used in the retouched to basically make all the retouched logic. So basically we're duplicating this here. We are searching for our PDA that give us the character data structure where we get the tags, so we can set in this new skeletal mesh actor the tag that correspond to the animation. Okay, and we will have to add also an animation, materials, collisions, everything. Okay, so let's start with this one. Okay, second, we'll break again, and this time we need to set the anim instance class, this one, the animation, and we get it from here, and close all the rest. Okay, there. So we're setting the the tag for the retouching and the animate class, and finally we need to set visibility based an in-tick option to always tick pause and refresh bounds. Okay, this one. This is needed because if we don't set this, the character will stay static. It will not refresh the bone. You don't have animation. Okay, the last one. Okay, the first thing that we're gonna do is to break this again, and we need to check if this skeletal mesh asset is valid. And remember that when we set the PDA, okay, here for example, we have the option to set this or not. Okay, we can use mutable data or skeletal mesh asset data. Okay, we will use skeletal mesh assets for the UMF mannequin and the skeletal mesh if we want to use just the skeletal mesh, but for our Metahuman we'll use the mutable object. So we first check if we're using this thing, and if not, we will pass through the mutable object. So the first thing is to check if we have something in the skeletal mesh asset. Okay, if not, we will use the mutable data information. Okay, the first thing is to set the mesh. Set skeletal mesh asset there. So if we have an skeletal mesh asset, we will set it. Okay. And now the materials. We have the material here. So for each one of these materials, we'll set the material. Okay, set material. Okay, set material. The element is here and index is here. There. Okay, and what happened when we didn't set the skeletal mesh asset, but we have a mutable data information? Okay, let's get this, break it, and now we need to check if we add a mutable object. Okay, because maybe, I don't know, maybe we didn't add any here because we forgot it, so we need to check that is valid. No, here, not valid with this. Okay, so if we have a skeletal mesh, we set it in our new skeletal mesh component and set all the materials. If it's not, we check if we have a mutable object, and we will use our character creation to do the magic. Remember that in our character creation we have a function called set customizable object, this one. So if we have a valid customizable object in our skeletal mesh, the one that is not valid, we will add a customizable object and a component name. Okay, there. I think that this is done here. We are done here. Okay, so basically we set the tag, we set the animation, we fix something here, and we check if we have a skeletal mesh asset and complete all the information with the skeletal mesh component, the asset that we want to use, the material that we're going to use, and if we don't have a skeletal mesh asset, it means that we will use a mutable object and we set it here. Okay, and with this we have basically everything related to the visual, not the collision, not the assembly, but at least the visuals. Okay, let's make a quick test. Let's go to our creation bound. Here we have a character assembler and one mannequin. There's nothing here. And we said this before. Let's connect this again. In fact, we don't need this. We will delete this later. Okay, so basically we're spawning a component. In this case, it's the main mannequin and the UFM mannequin. We have this tag and the name class. However, there's nothing here that say that this skeletal mesh component need to be or have to be attached to the thing. So we didn't assemble the character yet. We have just two meshes, 1 and 2. So if we hit play, there we have the first mesh and the second one. The first mesh is a valid one because it's used the UFM mannequin and the name class, so it's perfect. There is no mutable data, we have the basic material, but the second one, this the relation for mannequin, it has the retouched. We don't have an assembler because even if we have the data asset, we don't have a mutable information here. But look at this, we have our UFN character and our UF4 mannequin. Okay, and these two are not attached to our creation bound. So we have the creation bound and we have two skeletal mesh assets that were spawned here. So we need to assemble all this inside this blueprint. That's why, because that's the reason why this UFO mannequin is not moving, because it's not attached to this one and the retouched is not loading basically, based on the tag. Here we have the tag. Okay, so we are passing the tag correctly. Okay, so it's working. It's not yet, it's not ready, but all this is working. In order to see if the character is actually moving, we need to go for this part, but we need the mesh collision first, because here we have two meshes and the character creation bound separated. As soon as we put all those inside this, we will have collision problems, so we need to fix the collisions and then we will assemble. Okay, set meshes collision. We'll get this. We'll find the root. Okay, the root. Let's make a quick check, which is always true because we have the root. And we will need to recreate all the collision setup of basically all this here, okay? Because if we hit play here and check for our UFN, we have something completely different, okay? This is not this, okay? So we need to restore the collision preset. So I will make a quick copy and paste, and I will go one by one. Okay, first set collision profile name. Okay, just grab from here, set collision profile name. custom and update overlaps, which is basically custom here. Okay, this one. Next, set collision enable to query only no physical collision, which is this one. Query only no physical collision. Remember, I am just recreating this inside the code. Next, set collision offset type to pound. This one, pound. Set collision response to all channel to ignore. Okay, we'll set all this to ignore, all of them, and then we will change this, and this form. So we need to change word static, word dynamic, physics body, and destructible, because we set everything to ignore. So set collision response to channel word static to block, word static to block. Set collision response to channel word dynamic to block, word dynamic to block. Physics body to block, physics body to block, and destructible to block, destructible to block. So basically we set this to custom, query only, pound, we set all to ignore, and then we change this for this, and this to block. Okay, that's for the root. Okay, so this one, remember that this is the root. What happened, for example, when we have another character, this is our root mesh, we're replicating this, but the one that is below this one, it has no collision. So for each part, and this is the same for, I don't know, for example, let's use a Metahuman. Metahumans, we have the mesh with the setup, and then we have no collisions, no collision, no collision, no collision. Okay, and the air is physical. Okay, I need to fix that. I forgot that. Okay, but for now, all the meshes are set to no collision. Okay, I will update later, but we need to add here the ignore rule to all the other meshes. Okay, not air meshes. So we grab our body mesh map, the one that we created here with all the spawned meshes, and we'll get the keys, and we'll iterate through all of them for each loop, but we need to search that they are not equal enum root, because we set the collision for the root here. All this is the root. For all the ones that are not the roots, okay, we will set it to no. Okay, so all, in this case, in this example, the mail is just one mesh. Okay, we have the UFN, which is set to all this setup, and the UFN4, which will be ignored. But if when we have a Metahuman, this will make sense. So we need to search, find, using this enumeration. Okay, and we'll set the collision here. Okay, so set collision profile name to no collision. Okay, done. have the collision for the root, and we have the collision for all the other meshes. After we complete, I will make something here, our roots, comment, add the collision for the grooms to do, add the collision for the room, okay? And then we'll return. Okay. We will do that later, okay? Okay, so we have everything except for the groom. We will focus on that in other video. We have the mesh collisions. We can test that. Okay, our UFN has custom query only, bound, and everything ready. Okay, orthostatic, word dynamic, fixed body, and destructible. And this one is no collision. Well, we're almost there. Okay, we need to assemble the character and hide the root. Character assembly. Let's create our body mesh part and find the root. Okay, and we promote this to a local mesh, and this is for the time being our root. We'll change that later. Okay, and now we will search for get owner and the root component. Now, which is the owner? If you remember correctly, this is the assembler, and the owner is the creation bound, and we need the root component of the creation bound, and we are going to attach component to component. Okay, but the parent is the root component and the target is our local mesh. Okay, and we will not use any socket related. That's it, just that. Okay, so we're just attaching the root, which is the UFM mannequin. So let's test this, and look here. We have our UFM mannequin attached to our creation bound. We need to attach this and all the other ones. Okay, this first one is easy. Okay, we are keeping all the collision and everything. This part is a bit more complex because we will have one per component per skeletal mesh component. Okay, and we have a map. So okay, before we continue, we need to do some check first. We need to see if the data asset that we added here, this one, has a is Metahuman flag enabled or not. It's not a flag, but I will call it flag. Why? Because the order in which we're going to attach skeletal mesh to the root will be different depending if we're using a Metahuman or not. Basically, okay, let me show you an example. Look at this Metahuman. We have the root, okay, this root with the UFM mannequin, which is hidden, okay, that is there, okay, it's hidden, and then we have the gameplay camera and the body, which is just the feet and the hands. Okay, yeah. And this is actually the root of all these skeletal meshes that we have below. So we have this in the hierarchy, then we have the body, and then we have all these four. This is how Metahuman works with game animation sample. You have the body, and then you have all this one. If you load a Metahuman, you have something similar. Let's open Roy, but without the root mesh. Okay, we just start with the body. That's my dog, which is waking up from the nap. Okay, so for example, here you have the body, and then you have the four meshes. Okay, but the root here is not doing anything. Here the root is basically this mesh, but the setup is the same. You have a body and 1, 2, 3, 4 childrens, and the face is the root of all the groms. Now, if we have something completely different, not a metahuman, maybe we have the root and all the bodies, all the skeletal mesh below. So we need to consider that if we are loading a metahuman, we need to reset or initialize again, reinitialize this local mesh with a new root before we add all the other meshes. But if we don't use a metahuman, we can just add one mesh after the other, and all of them will be attached to this local mesh. Okay, that's basically what we need to do. We need to do something if we're using a metahuman, and then come back to the fourth part where we are actually attaching all the other meshes. So let's copy this tree, paste it here, but in this case we are searching for the body. Okay, and we need to attach component to component before we rewrite this local mesh. Okay, so we will attach the body to the root. That's the first part. So the local mesh is the parent and the body is the target. Okay, and after we do that, we will set this local mesh to our body. So we are saying, okay, this is the first mesh below the root, and after that we can keep adding all the other skeletal mesh. Okay, I just added a quick branch here to check. This is not needed, but just in case that we don't have a body. Okay, we're almost there. Now, in case that this is not a metahuman, or in case that we are finished with the metahuman part, we will have to iterate to all of the rest. Is for each loop, and here we don't want to iterate through the none. We don't want to iterate through the root. Okay. So after we get the root, if we are not using a metahuman, add all the others. Okay, and if we're using a metahuman and we have set the local mesh, we can come back here. Now, pay attention that we are not searching, we are not avoiding the body and say, okay, Banti, but we set the body here. True, but maybe if we're using the Metahuman, we will set the body here, and if not, we'll set the body here. And if we're using a Metahuman, we will also search for the body here, which is a problem. To fix that, we need to do some code magic here. So I will check here, and I will use a select. And if we are not using a Metahuman, we'll just avoid using the non under root. And if we're using a Metahuman, we will add the body to the exclusion, basically, to the mesh that we're going to exclude body. Okay, so let's check this quickly. If we are not using a Metahuman, this is going to be false, so we're only excluding the non under root. If we are using a Metahuman, this will be true, and we will exclude the non under root and the body. Okay, there. So if we follow this route, we're setting the body, we're attaching the body to the local mesh here. So we have our new root, the body as our new root, and then we will go through all the others except for the non, the root, and the body. However, if we are not using a Metahuman, we have only set the root here, and we need to exclude the root, the non, to avoid problems, but not the body, okay? Because this will be false, and we will skip this part if we are going to this root. Next, we get the body mesh map, and we'll find the next in the map that is not a non, it's not a root, it's not the body, depending on if we're using Metahuman or not. And here I made another check, which is completely futile, useless, which is not equal to the local mesh. This is not needed, really. It's not, because the local mesh could be the root or the body. The root is skipped here, and the body is skipped here if we're using a Metahuman. Okay, if we're using a Metahuman, we skip the body, so it's not needed. But I will make a double check. Okay, so we're not using any mesh, any skeletal mesh component equal to the new parent, because it's the parent basically. So we need to attach component to component again. The local mesh is the parent, and this is the target. Okay. There, beautiful. Beautiful order and symmetry. Okay, we're almost there. Let me check this quickly. This is correct. Yes, we're almost there. So there's just one thing that we need to check, which is the height. That I will do it later, but for now, let's test this. Oh, voila! We have the creation path. We have the UFN with our collision ready. Then we have the UFN mannequin. with our retoucher, with our materials, with all the collisions to ignore, and with our tag here. And because this mesh is a child of this other, and this retoucher is looking for this AVP sandbox character animation, with the corresponding tag is actually loading all the gas functionality. We need to do two more things. One is to fix the position of the feed, that in this case has no problem, but when we are using Metahuman we will need to fix that. And the other is obviously to hide the root. But we're almost there. We're almost there. Okay, this is the code that we're gonna add. All this. After we finish everything, we're searching for the body, and we will add a local transform. Okay, the body. Okay, and the transform comes from the height correction from the character DA. Okay, this character DA height correction. Okay, and we will add it to the feed. Okay, just grab from here, break it, make transform, and the location in this one, split and connect this here. Okay, keep the rest. Okay, keep location 0 and X and Y, no rotation, no scale. This is needed because some character has some height difference, and you need to adjust that here. Okay, we're almost there. We just need to fix the visibility of our root component, but we finish with these three functions. Okay, we'll add a new custom event, call it set mesh visibility. We'll have an input that says on, and we'll search for the root and we'll set the visibility but we'll use this, and what we're going to do is to search for not boolean and check for propagate to children, and I will explain what we're doing here. So basically new visibility is set to none, so the root will always be hidden, and if you want to turn the rest of the mesh on, we don't need to propagate that invisibility to the children. And if you want to hide, so this should be false, we will set this to true, and we will propagate the children hiding all the mesh below the root. Okay. We will check that here. After that we will search for the name is set mesh visibility, the assembler, sorry, set mesh visibility to on, and there you have it. Okay, we have a problem with this material. Okay, let me check what is happening here. Mannequin male, body materials. Look at this. I am not searching for the logo here. There is a logo. Let's check the male too. The female, the logo is there. Okay, there you have it. So we have the first mesh hidden, and the second one, which is the one that we're going to use. And the good of this is that if I change this to female, I have the female now. And pay attention to this height correction. Okay, so let's use that height correction that I was talking about. Let's use -1. Okay, that's great. So it's working. Let's make a quick test. Character template, duplicate. I want to make a Metahuman template. Metahuman template to speed up the process with all the others. Is Metahuman true? We'll keep the root. We'll add 2 more. One body and one face. Okay. The tag is in the body. So we will replicate the gas setup for Killer, basically. So the body has this name retarded, so body is this one. The face has this one, which is in gas, Metahuman, etc. Be careful, because here in Metahumans you have in common the same one, so just be careful. Use the one that is provided inside game animation sample. There have the 2 and MVP, and in the body we need the tag. The tag for Metahuman is all this, so body tags there, and that's it. This is our template for Metahuman, which is basically the same that I did here, so I will just delete this one. And if I want to make this for one of the, how many Metahumans mutable objects I have? Only 2. I could have 4 more for figure, etc. But I will just use these 2. So let's make one. This will be Roy, and character will be Mutable Roy. We can change that later. It's gonna be male. We will use this in the UI. And here we need to add the mutable data. Okay, so mutable, where I have mutable Roy here. Come on, don't crash. There. And here we there. And we need to add the component name. Okay, the component name, if you remember, bodies is the male body. This is the component name. Wait for Mutable to compile. Come on. Okay, the component name, this is the body, male body, and the head, this is the name of the head. So we have in the body, we have the same mutable object in both, in the body and the face, but we will load the body using the component name male body, and we load the Roy face using the Roy head here, and nothing more. Okay, nothing more. If I use Shigeru, I will have a Shigeru, but that's it, Roy. Okay, so let's go with here and select our Roy, and there you have it, and it's working. Yes, I know I have a lot of textures, but high correction. So if I remember correctly, it's 1 minute 1.5. There. Yep, it's working. It's working. And let's do the same for Liz. Dimension plate, duplicate this Liz. Okay, this is gonna be Mutable Liz, female. No. Mutable data. Liz, mutable data, Liz. Female body, body component name female body, and the head is gonna be Liz head. Face, mutable object, Liz face. Okay. And here let's select now Liz. Sorry. Actually, I'm tired of that. So let's create a pawn there. We have no more. Okay. I think that is like -2. Yes, -2. So, guys, you can switch characters just using the data asset. So, once you finish with your mutable object, and you create the corresponding data asset here, which is basically using the Metahuman template, change the mutable object and the component name in the body and the face, and that's it. You have the new character. Probably I will add more things in the future because we're just starting with Mutable, but you don't need now to create all that spaghetti of characters and components and everything. You just need to add one character assembler and switch there. Now your question will be probably, Martin, how can I load multiple characters? Remember that we don't have the face yet, the AR yet. How can I add multiple characters? Because we have only one here. Look at this. We have the creation pawn, the root, the body, and the face. Okay, and this is mutable. Okay, this is virtualized. You don't have a skeletal mesh here. We're literally using mutable. Okay. Okay, literally, look at the name. Ancient transient, list head, all this. This does not exist here. We can actually bake this, but this is mutable and it's working. So the question will be, how can you add multiple character and use this button? Well, we need to work here in the character assembler. Okay, here we will load all the characters. We will decide what character to load, which one can be hidden or unlockable later in the next class. Okay, that's it. I hope you enjoyed this class, and I'll see you in the next one.